And in physics, the common unit that they use is called a joule. They define a joule is if you were to push a 1 kilogram mass with a 1 Newton force a distance of 1 meter. It's not very much energy. A joule is a very small amount of energy. And you can see that a AA battery has almost 11,000 joules packed into it. That doesn't really power up much. When we talk about how much energy a country uses, especially over the course of a year, obviously we get gigantic numbers of joules. So joule does not work when we apply this to meeting a society's energy needs. It wouldn't even apply to your own house. We're going to measure that in much larger units as well. But there is a unit we've come up with. We call them quads. A quad, you can see, is a quadrillion kilojoules. And the prefix kilo, we know, means 1,000, right? So we have 1,000 quadrillion joules is a unit of measurement. You can see that the United States, on average, goes through a quad of energy about every 3 to 4 days. And once again, we are energy hogs, 25% of the world's energy use. I found this map very interesting. You can equate a particular state's annual energy use in 1 year to other countries around the world. So Indiana, we use the exact same amount roughly of energy as Pakistan does each year. Now, one of the main units that is used in environmental science, a lot of products are rated using this unit. We talk about something called a BTU. It stands for British Thermal Unit, and it's usually applied to heat. But that's not actually what it means. It is the amount of energy that you need to change a pound of water by 1 degree Fahrenheit. You could heat it up by a degree, but that means you could also, how much energy would it take to cool it by a degree? That would apply as well. That would be a BTU. That's why I put an air conditioner down at the bottom, right? It's not always heat that we're measuring. How much energy to make something cold, right? Refrigerators could be rated in BTUs. A BTU was set to the standard of a kitchen matchstick. A wooden kitchen matchstick is supposed to have 1 BTU of energy in it. If you could burn that matchstick all the way down and capture all of its heat, that would be a BTU. So it's not very big either, right? 1 matchstick. I mean, yeah, you can make a test tube of water heat up. You can see that a BTU, though, has over 1,000 joules in it. We get very big numbers again. 1 quad is 10 to the 15th BTUs. Gigantic, huge numbers. We're going to do some math probably Friday. There's really 2 kinds of math they love to throw at you on the AP test. They love having you work with exponents. And so we will do some of that. And they love having you do unit conversions, switching from 1 unit to another. So that's what I'll be showing you on Friday. And these are what we call conversion factors, right? Because they're equal to each other. So we can multiply them and they equal 1. They don't change anything. So these are some important conversion factors that you might have to use eventually. But if you buy a house someday and you go through 4 furnaces like I have, that adds up pretty quick. You want to, engineers actually pay attention to the power ratings of appliances. And so just for comparison's sake, I put some standard items and what their BTUs are. Now, there's some other standard units that we use in environmental science, and it has to do with the fossil fuels usually. And we can convert all of these to BTUs if we want. We can do all those equations. It's not that hard. For coal, we typically measure that in tons. And technically, there are these things called short tons or long tons. Don't worry about that, but you might see that at some point. What they are is English units that are close to 2,000 pounds, but not exactly 2,000 pounds. So that's the difference between a short ton, a long ton. A ton of coal has the same amount of energy in it as almost 4 barrels of oil. 1 ton of coal equals 3.8 barrels of oil. A barrel of oil sold on the international market has 42 gallons inside. 42 gallons of crude oil. That's going to be equal to 58 therms. What's a therm? A therm is a measure of heat used for natural gas. Natural gas, when it's dry, it can also be measured in terms of area. So that would be cubic feet. You can see 1 therm of gas is 87 cubic feet, and that is equal to 105 BTUs. So I really want you to, on this slide, know that coal is tons, oil is barrels, and gas is therms. But all of the information you need is there to convert to any unit you want now. If I want to put tons into BTUs, well, I could change my tons into barrels, my barrels into therms, and my therms into BTUs. It would take a bunch of steps, but I could get there. I could convert across all different types of energy. One thing I want to point out is just a misconception that a lot of people have. What's on your screen is charcoal, which we use in like a camping grill, right? If we're not going to bring the big propane tank with us. Charcoal is kind of misnamed. It's not coal. And a lot of people think it is. They think there's coal in it. Charcoal is actually made from wood. It's biomass. It's made from wood. And what they do is they char the wood and they create this very carbon dense remains of the wood that they burned. And they kind of pack that all together and take the air out of it. And so it's very energy rich. Have a good one. We'll see you later.